Good evening, everybody. Welcome back to the stream. It's a pleasure to be here. Let's sit down and bang out some code. So, where I was last time, I'm trying to get paging working, and there's a lot of underneath that needs to be put in before it'll work. And I've done a little bit of work off camera. So, what I need to be able to do first, or what I did last time, I suppose, is I made some lovely... hold on. Go away. So I made some lovely new classes here that can hold the data for page directory and page table entries, because those are necessary. And then so what I was trying to do, nope, this one, is now implement functions that will allow me to ask for new frames. So I've decided to begin the area of memory that I'm allowed to draw frames from at the 1 GB location. I don't have a way to actually know how much memory my system is running at the moment. That needs to be put in. So you may... I mean, I know in my virtual machine here I'll have access to all 4 GB, but if you're running it on some random, Dell machine that you found at a pawn shop, you might not have 4 GB available. So you need to... There's a way you can figure that out, but I don't have that at the moment. So for right now, I'm just hedging my bets and knowing the fact that I've got all 4 GB at the moment. So I've decided to say, starting from gigabyte number 1, starting at gigabyte number 2 and going to gigabyte 3, there's 1 GB of what I call the field, the frame field. That's just the location of memory that I'm allowed to create frames from. Right? Yeah, so I've got 1 GB worth of frames. I doubt I'll come anywhere near exhausting that anytime soon, which is fine. And then to go along with that, I've also created what's called the frame field bitmap. So this is how I'm going to keep track of what frames are being used at the moment. So frames are exactly 4 kilobytes in size. That's just the way it's set up. So there's a finite number of them inside my frame field. I don't remember how many that was. I was doing the math on it last time, and the math was really confusing me last time. But anyway, so there's also so this frame field bitmap is just going to be a long string of bits. I set it up as integers, but it's an array of this many integers, and is that exactly how many frames I've got? Yeah, so this number here must be exactly how many, no, it's not, I'm sorry. It's this times 32. Hey, every-release. Good to see you. Thanks for joining me. I'm just kind of talking through where I was last time. I'm glad that's what you want to see. Let me think here. So the idea here is that there's one long string of bits, and there's 1 bit for every frame, and so we can keep track of which frames are being used in the frame field bitmap by setting the bit that matches it to 1. So there should be exactly the same number of bits in the frame field bitmap as there are actual frames. In fact, here, let me draw this to help me wrap my own head around it a little bit. Let me show you. So this is memory. Oops, you can't. That's bad. Too high, too high, too high. There we go. There we go. That's memory right there. And so what I've decided is at the 1 gigabyte mark. Here, let me. So pretend this is 4 gigabytes here. So we got 1, 2, 3, 4 gigabyte sections. That's all you can get with 32-bit processors. Right? So I've said from this location right here, up here, that is the 1 gigabyte point. That is right here. So I'm saying from this point to this point right here, this is the area that I'm allowed to define frames in. I'm allowed to pick frames out of this. And frames are defined to be 4 kilobytes in size. So however many 4 kilobytes goes in there, you know, that's how many frames there are. And they're all the same size. So there's a finite number of frames allowed to be chosen from in there. And that's what frame field is. So frame field is just saving the starting location. And so I can index into it plus, so I can do frame field location plus some multiple of 4 kilobytes to get to a new frame. And to keep track of which frames are being used, that's what this frame field bitmap is for. That's just a big, long array of integers. And I'm only using integers because integers are already 32 bits, but I'm really only interested in the individual bits inside them. So there's enough individual bits in that array to keep track of every frame. I should probably go back and check the math on that. But there should be 1 bit for every frame that's inside our frame field. And so it's like this. So you got, you know, imagine kind of like this. It's just dot, 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 dot. So every time we use a frame, say we grab the first frame, we'll set the first bit in the bitmap to 1 to say, okay, he's being used right now. And so the next time we go to grab a frame, we'll jump in here and say, oh, he's being used already. We'll go to the next one. Oh, hey, he's not being used yet. So we'll set this guy to 1 and take the next frame. And theoretically later, I haven't tried it yet, but when a frame can be released, we can say, just set him back to 0 again. So the next time we need a frame, we'll bounce along and hit that 0 first and say, okay, we'll just use that one. And then so as we go on, more and more frames will eventually be used and freed, and yeah. So, but that's what the frame field bitmap is for. Okay. So what I'm trying to do right now is see if I can select empty frames based off of the frame field bitmap. Okay. What happened to my... There we go. My mouse slowed down. Okay. Oh, good. I'm trying out this this drawing idea because it kind of helps. I feel like it kind of helps with abstract concepts. It helps me anyway. I think it's useful. So, let me show you what we've got here. So I've already made this. I did some work off camera the other day, but I've got this function here called find a new frame. Oh, a decent drawing app? Milton? Interesting. Why do you recommend that one? Make a note for later. Casey Muratori. I can't say I know who that is, actually. Is that someone I should know? Oh, Handmade Hero. I've heard of that stream before. think I've actually ever watched it before, though. Okay. Interesting. Alright, so where was I? Oh, yes. Okay. So this find new frame function, all it does is return out a void pointer. That's an address. So what we want is an address, a memory location, which is the beginning of our frame. And that's what this guy does. So when I call this, I should get an address back that's of an unused frame. Yeah, so here, let me go ahead and show you. So if I just go ahead and run it right now, let me show you the kernel. I have a test here that should search for new frames. So if I save an address and ask for a new frame, this guy should be the first unused frame, and then I'm printing out what that address is, and then the next time, it should be the next unused frame because the first one's already being used. But my problem right now is that it's not moving on to the next address. So this first one is correct, because remember I started at the 1 GB spot, that 4 zeros everywhere. So that's correct. So I expect the first frame to be that address, but then the next one should be that plus 4 kilobytes. And it's not. So it's popping out the same one. So I need to figure out why. So the way I'm doing it is when we jump in here, we have a for loop. I guess I could just do size of this, can't I? But anyway, so we're just doing a for loop that's of the same number of slots because they're both integers. That's terrible, I know, but it's what it is for right now. So then we're gonna go through the frame field bitmap at every index. And then we're gonna check to see if it's equal to maximum integer. If it's not equal to maximum integer, that means it has a free spot in it, right? Because an integer is 32 bits long, and FFFFFFF, whatever it is, that means every bit in there is full. If it's not equal to a maxed out integer, that means there must be a free bit in there somewhere, which means we have a free page. Or that means there's a reference to a free page. Or, I'm sorry, frame. We're dealing with frames right now. So if we hit an integer that's not already maxed out, then we know there must be a free bit inside there, so now we gotta find it. So I just save off the current one because I need to do some bit math on it. I called it bitmap copy. So now, on that integer that we found that has a free bit in it, we're going to check to see if it's equal to this number right here, which means I'm pretty sure I got that to mean if the most significant bit is a 1 or not. Oh, wait a second. Did I get that backwards? Is greater than... No, that's correct. It's great. Yeah, so if it's greater than or equal to this number, that means the most significant bit, the leftmost bit, is a 1, and that means that one's not any good. And so then what we'll do is we will just bit shift everything over 1, and then do the check again to see if a 0 moved into the front spot. Well, here, this is actually a good spot to draw again. Let me erase all this. So we get into this loop with an integer, or a number. Let's just pretend, for example, it's 110100. I don't know. So what we're going to do is we're going to see if that number is equal to... Well, here, let me move this out of the way so you can see. There, like that. Is equal. We're going to see if that this number that we saved, which is in here, is greater than or equal to this, which in binary, I'm pretty sure, I believe I got it right, just means the most significant bit is a 1, which would be this. right? So we check to see if our number is greater than or equal to that. So that would indicate that this 1 is present, which means that bit is in use, so we can't use that one. So then we do a bit shift, which shifts everybody over 1, effectively destroying this one. Well, no, wait a second. That's still there. It effectively destroys that first 1 and taxes 0 on the end. Then we check again. Is the first bit still a 1? It is, so we can't use that one. Okay, shift again, destroy that one, and add another 0. Check the first bit again. Oh, look at that. It's a 0. We've just found our free bit. And so now we've been keeping track of how far we've gone in. That's with index right here. So now index should be how many times over we have shifted. And so we know how far into this integer is our free bit. Right? Right. And so then after we break out of that loop, we now have saved off what I called them the major and the minor. So the major index is the index into the array, the big of integers that we found, and then the minor index is the index of the bit into that integer that is the free bit. Right? So what we're supposed to do is we need to set that bit to be 1 now, because we're now going to use it. And that's what I thought I was doing here. So now it's frame field bitmap of major index. That's in the array up here. We shift a 1 in minor index. Oh, wait a second. Oh, I might have that backwards. Because this temp index is counting how many times in from the left we're coming, and this bit shifts in from the other side. So I think I need to do size of int minus that number. Oh, you can't see that, can you? I'm right here. I'm right here. So what I might have been doing wrong is I was keeping track of how many times inward we're shifting this direction. So in this case we did 2, but this right here, what I had before, this shift in from here, that's shifting in from the other side, so that would have moved us in here. And that would have set this bit to be 1 instead of the... No, I'm sorry, wrong number. It would have set this bit to be 1 instead of this bit to be 1. Because the problem that would be happening, that would be causing the same memory location to be picked again, is that the bit that represents it in the bitmap is not being set to 1 to show that it's being used. So if I'm setting the wrong bit to say that it's being used, next time around it's still 0 and pops out the same address. Shoot. That didn't do it. Okay. I think that what I just changed is still correct, though. Okay, so what am I doing wrong? Let me make sure that this number here is what I think it is. Calculator. Okay. So in hex, I said this is 0, 1, 2, 3. 1, 2, 3, 4. Right? See, so this number right here that I have it checking against, in binary, it's all zeros with a 1 on the end. So that's correct. So that if we... I guess this could be an or an and. Actually, instead. instead of checking if it's greater than. Because if it has any other number in here, there will also be other ones thrown about. But I only care if that one is here. But this number is greater than this number. So it needs to be equal to or greater than. But this could just be a bitwise and, probably. Because that would only check the first bit. Yeah, that's probably smarter. No problem, every release. Thanks for stopping by. I appreciate it. See you, man. Get some rest. So if my number and a 1 at the front are ANDed together and it's true, then do that. That makes sense. Did that break anything? Nope, still the same. Same output. Didn't break anything though, but that's fine. So that leads me to believe I'm not, this calculation here is wrong. Let me pull in, I guess we should do some debug printing, I suppose. Libc standard IO. Okay. So what do I want to print out? So can I print out, I don't have a binary. I guess I could convert it to binary with the calculator. I guess I could print out, no, I want, no, I do want that one. I can print out bitmap copy. Let's do it in hex. So that's before. And let's do it again after we have supposedly... Oh, wait, no, I want to print out that one, don't I? So after we edit it, supposedly, and see what happens. To see if the bit that I expect to be changing is actually changing. Oh. So that's in hex. Where's my calculator? Let's try and make hide nor hair of this. So in hex we have that. So in binary we have that. That's not what I want at all. Oh, that's interesting. So I want the first bit. Yeah, see, so look. It started out as 0, which is good, and then after all this, it's now 10 in hex, which is what put this 1 in here. That 1 is in the wrong spot. That 1 should be at the beginning. Oh, I have a crazy little hunch. What if I keep... No, it's not going to do it. Okay, yeah, so that tells me that this calculation right here is messed up. So what exactly am I trying to do here? So I want... Let me go back to what I had earlier and see what it pops out. Maybe I had it right to begin with. Oh, look at that. Oh, that's 1 in hex, which is still 1 in binary with all the zeros. Yeah, so it doesn't show all the zeros, but because it's 1, that means it's at the very least significant bit, which is 1 with all the zeros in front of it. I want it to be the other way around, which is 1 with all the zeros behind it. Can I just go that way instead? Didn't change anything. Huh. So minor index is how many times I've gone in from the most significant bit. This portion right here is not working. Frame field bitmap major index. This is correct because that's the int portion that I'm looking at. Equals... No, that's exactly what I'm doing. Hold on, I'm trying to think of a smarter way to do this. Shift right. That should be size of int, so I don't know why that... 32 minus 1. I want to go from that back side. Yeah, that didn't work. How big is it? So why didn't size of int work? I feel like size of int should have worked. That's not what I expect. What if I print out major and minor index too? Major. These are decimals. Major and minor. /n. major index, minor index. What? Oh, there's still 0, 0. That makes... Well, that makes sense, yeah, because we're in the first element of the array, which is the 0th slot. And the first bit that was checked was the empty one, so that's the 0. We had to move 0 times. Oh, should it be +1? What if it has to be +1? Because moving in 0 times means the first bit. So do we need to go 1 extra? Let's try adding 1 there, see what happens. Didn't work, but... Calculator. Oh, wait, I get it. Size of returns number of bytes. That's why it's going in 4s. So size of int is not 32. Size of int is 4. And so I'm doing 4 minus 1. It's treating that in bytes. That's why size of is not working. So I'm wondering if I could do it with some funky arithmetic. So can I do... No, I think I'm on the right track. I want to do a 1 shifted over 32 minus minor index. Didn't I already try that though? I think I already tried that. Yeah, that didn't work. What about 30? Do I need to go 31? Oh! Look at that. That looks promising. So see, we had 4,000, and then the next one we did was, or 400, is that 40 million actually? Yeah, 40 million, but then we had 40 million and 4. And our minor index was 1. That means we had to go another one over. There we go. Okay, so I'm going to take out that printing, and let's allocate another one, see what happens. I don't think I need to redefine this every time either, because I can just... Oh. Nope. Let's just do another one, because we should advance again the next... next memory location. Look at that. Zero, 4, 8. There we go. I think that's working. Oh, I sewed out this one over here. Okay, let me, oh wait, that's not what I wanted. I commented out the wrong one. Yeah, so that's our the bit field before and after, and that's the memory location. Then there's the before again. See, it's 8. It's 8 again. Then it came out to be C, and the after is so 8, 9, 10, 11. Yeah, so it would be the most significant bit of that final byte would make it 8, and then the next one next to it would be 8 plus 4, which is 12, which is hex for is C in hex, right? 9, A, B, C. Yeah, 9, 10, 11, 12, A, B, C. Yeah, that's right. So that means the two most significant bits now for that C are 1. And then we do it again. So we start out with C, then we went to E. So then it would be 8 plus 4 plus 2, which is 15. And then I bet you if we did it one more time, that would turn into F, because that'd be 8 plus 4 plus 2 plus 1, which is 16. And then after that, we would jump to the next character. We would get F1. Let's try it. Yep, look at that. There it is. See, it's hard to see. It's F right there. Yep, so we went from 0 to 8, 8 to C, C to E, E to F. And then just for kicks and giggles, we'll do it one more time. It should go to F, and then 1 in the next character. Or 1 in the next byte. Oh, F8, sorry, yeah, because it starts from the most significant. Yeah, so at the bottom we went from F to F8, which means, because 8 is the most significant bit, so we're counting backwards from the most significant bit downward. That's so cool. And see, our memory locations are going up. From 400 million to 4,000,004, 4,000,008, 4,000,000 C. In increments of 4 kilobytes. I love it. Love it, love it, love it. So now what I probably do is release the frame too. Which is to say, set its bit back to 0 in the bitmap to show that it's ready to be used again. Let me get rid of some of these. So all I really need to do is just figure out its offset from the start. So from the beginning of the frame field, which is the 1 GB mark, I just need to figure out the difference between the pointer that is passed in and the starting point. Then I can divide that down into divide by the size of one block, which is the 4 kilobytes, and that'll get me back to an index that I can set back to a 0 in the bitmap. Ugh. Coffee's cold. Ugh. Cold coffee is should not be for human consumption. So what do I want to do? So I need to oh, these are integers. Maybe I should take it in as an int. No, then I'll have to cast it all the time. I can just cast it inside. How do I do this? I need to figure out how to get the difference. What if I just cast them to integers? Oh. Offset equals int frame field minus. Nope, I got that backwards. Int frame minus frame field. So if I convert them, they're originally both pointers, but if I convert them to integers, that'll turn their addresses into numbers that I can subtract. So if I subtract the frame that I passed in, which is supposed to be bigger... Oh, I should probably do a check there. Because frame field is the start, so I want to make sure, I should do a check there to make sure that the address that I'm passing in fact bigger than the beginning of the frame field and not before it. Because if the address is bigger, that means I know it's after it, where it should be. So there should definitely be a check there. And I believe this is already going to be in kilobytes, is the thing, because... Remember when I showed it, the memory location it was picking was just going up by 4 in the hex. So I think that's already being measured in kilobytes. Right? Maybe. Oh, wait a second. I'm not. I'm not. I need to multiply by my frame size, which is 4 kilobytes. I was only adding the size of an integer 4 times right here. So return my frame field plus the bitmax mask index. I think I need to do times. What did I call it? Frame size. Whatever. Unused error. Yeah, whatever. Hold on. Unused parameter. Ah. Fine. Stupid compiler. Okay, so now we got 4 up here. But is that right either? I should... My math shows that I should have this many frames available in my 1 gigabyte. Man, this memory math is kicking my butt. Hang on a second. It's a little warm in here. Turn on the fan. Hey, Stragger. Should be allocated 1,000 apart. Yeah, I think you're right, and I got 4,000 there, so there's a math error right there. It's pointer arithmetic that's goofing me up here. So frame field, that's the very beginning of where my frames are allowed to be allocated from, which is at the 1 gigabyte mark. And then I'm doing the bitmask index, that's the free field that I found, times frame size, which is 4 kilobytes. So that's supposed to be multiplying me into my frame field at 4 kilobyte increments. Unless this math is probably wrong. An int pointer. What's the type of field frame? I made it integers because I iterate through them, and it's easier to, and it would be easier to just check, 32 bit sections at a time. It probably doesn't have to be though, because if I want to do this onto it though, I'd have to cast it to something if I just left it a void pointer. Should be char sized. A uint pointer t, how big is that? Is that 8 bits? thought I was hoping I was making an efficiency here with making it an int and just checking bigger sized chunks at a time, but that might be what's wrecking me here. So you're thinking make that a char? If frame field's an unsigned int, then frame field... Well, you know, when you put it that way, that makes pretty good sense. What are you complaining about? Okay, there we go. So that, in theory, will make this work then, right? Oh, that's why I was getting multiplied by 4, because ints are 4 bytes. That's why I was getting 4 times what I expect. Oh. Unless I forget to save. Aha, look at that. So there's our first address right here, the 400,000. There's our second allocation at 401,000. Right? Oh. Let me try it again. And then the next one should be 402,000. Which it sure as heck is. Cool. Okay. Okay, now that actually looks like it's working now. Onto this. So I need to be able to free a frame also eventually. You can make frame field a pointer to an array of frame-sized objects. Struct frame, jar bytes, frame size, sure. Static, frame field, frame, the beginning. Oh, I see what you're saying. How would... Oh, and you're saying save... No. Well, because this is... The difference between pages and frames. Frames are the sections of physical memory that are allocated, and the pages are what they're mapped to. So this is the portion that finds physical sections of memory. So I figured, to me, it made sense that this is finding frames, and they're mapped to pages, right? Yeah. So what you're saying is I should make a struct that combines these two. So you say do something similar here to keep the actual beginning location, but then of an array of frame-sized objects. Why would I want to do that? Unless I can place that array of objects at the beginning at my frame field location. Is that what you're suggesting? Because what I'm doing is I'm doing that manually, essentially. I'm manually going through at frame-sized intervals. But if I created an array of frame-sized intervals, then I wouldn't actually have to do that math using the frame size. Is that what you're getting at? So like here, I wouldn't have to add this essentially. It could probably do that for me. If I had the ability to place an array at this location, then that would make it simpler. I don't know if I have the ability to do that, though. Can you statically make... Yeah, I don't have the ability to set stuff at a specific... to set new arrays yet, do I? I can only do it with... well, non-arrays, a singular of a type. Because where is... I don't think I have a new operator for arrays yet. Well, I mean, nothing a quick search can't figure out. That's specific address. Didn't mean to make an array object. Well, let me see what this has to say. Right now, frame field is a pointer to an array of bytes starting at this location. Point to an array of... You mean an array of frames? Let's take a look. Looking at my code? Yeah. Plus struct. Yeah. Yeah, that makes sense. An array of frames which are already of size. So static frame. Struct frame char frame. That's right. Oh! That does make a lot of sense. And because it's already... and because frame is already being... well, because frame field is now being treated as an array with units of a particular size, arithmetic is done for it. That does make sense. I like it. Sure, we can do that. That's what that's a frame. That makes sense. Singed. Signed. Char. Frames equals frame size. Like that. Yeah, okay. I'm changing this here to be oh wait, no. Unsigned frame hasn't made any sense. Okay, cool. And then this right here. That will index me in my frame-sized units automatically. Let's try it out. Oh. Darn. Freaking compiler. I'm busy right now. Nice. Same thing. Excellent. So, W error is cancer. I don't like having I don't like compiling with errors though, so I don't really think it's a bad thing to treat them all. Or I don't really like compiling with warnings, so I don't really think it's a bad thing to treat them as errors. Do you think that's not necessary? What was I gonna do here? So we're gonna do True. True. That's very true. I like having print statements just for debug purposes. I try not to compile using... I'm not a huge fan of preprocessor directives. So, but these are just either on or off. I don't like making actual builds with legit, like, if-defs and stuff. I'd rather just have them all on or all off. Actually, this right here is useful too. Make sure that works. Sweet. There we go. So after 3 page requests, or for 3 frame requests, we've got this. Excellent. Okay, so now what's been bugging me here? So I need to, in order to free a frame, frame, all I have to do is just mark his bit in the bit mask back to 0 again. So I just need to get the difference between... Well, actually... I think what I just did with the array might have actually helped me. Frame to free. There we go. So I already have a variable named frame now. It's permanent. Wait, do I really want this to return just an address? Because I made these lovely no wait, these are entries. Never mind. Yeah, no. Those are the table and directory classes. So I just need to know the offset of how many bytes my You've done this before? You've tackled this behemoth before? Do tell. Please do tell. Started work though, thankfully. No, this is the hands down the most insane challenge I've ever taken on. But this has probably been the most educational thing I've ever done too. Because like, don't have the runtime library to help you out or a fancy schmancy compiler to help you out and do cool stuff. It's all bare bones. It's kind of fun to see what I can get away with. So I actually don't need this anymore because frame field I need to get the number of bytes difference. So if I pass in a memory location, if I turn him into an int, and subtract that from frame field, which is my beginning location, I should get an offset in straight bytes, I believe. And so then I just have to set frame field bitmap of offset times frame size. Oh shoot, I gotta index into the bits actually. Dang it. I might want to change this to chars too, to make it easier. Because again, I was thinking I was saving myself an efficiency by jumping through 32-bit blocks at a time. But now it's just going to make it harder. Vector bool. I mean, I could just do an array of booleans, but bit set, there you go, or bit field or whatever it is. There's another one like that. Yeah, I keep running into all these little things that I really should like implement, but I want to add features. There's a number of things that I should go through and implement. Like a hash map would be helpful in a couple places. Like if I just went through and actually did vector, or at least like an official linked list type, because I use that for my heap. But it's all hard-coded implemented. If I broke it out into just a linked list type and used that, then I could use it other places. I really should. Alright, so what is this doing now? Since I changed this to be... Yeah, so I need to get... I'm trying to use every individual bit. Like, I could just use an array of booleans, but those take 8 bits each. Anyway, so that's a bunch of wasted memory. So I'm trying to squish it down by making sure this is the exact number of bits as I have frames. So if I do this, this will just get me to the correct index into here, but then I need to go in and find the actual bit that I need to set back to 0 inside each one of these. Right? Oh, my typing's messing me up too, though, because now I'm treating this is frame field is now in bytes. So this should be a difference in bytes. Maybe I should just do this in bytes too. Well, either way, I'm still going to have to use it. Well, let me just see how nasty this gets. I need to change this to match more of an integer, though, so that's got to be times, or divided by 4. I can't remember which one it is. Alright. There we go, yeah. So this is a number of bytes. I need to turn that into a number of integers, which is kind of nasty. I might change this here in a second, but I just want to see if this works. If this works, then I think I might go through and turn it back into bytes. Right? Yeah. So this will get me to the number index into the array of integers, but then I need to figure out the exact number of bytes that are through. Oh, I should do a modulus. No, bit offset equals offset modulus 4. Unsigned int, pointer, bits, address of frame, field, bitmap. Totally untested, of course. Here, let me paste it here. Let me so I can look at it better. Oh gosh. Thanks for the follow, DZ. DZ Dentu. Glad to have you. Dizzy Dentu. Glad to have you. Alright, so let me look at this here. So int pointer, this is the address of frame. Oh yeah, that should be address, shouldn't it? Dizzy. Got it. Cool. Well, I appreciate that. There's no lack of ambition here. Number of... Alright, so let me see what you're saying here, Strager. So 8 equals character bit, number of bits in a byte. That's right. That's these. That's correct. Size of int times a, the number of bits. Number of bits in an unsigned int. Yeah, that makes sense too. So address of frame field, the frame to free minus the frame field. Oh, I see. You're doing it all in one calculation. So that'll get the offset into my frame field bitmap divided by size of an unsigned int times 8. Why would I do that divided by... Oh, would that get me to the exact... Would that get me to the exact bit that I want to set? framed free mask. Field modulus has been unsigned int. That's okay. That's what I was getting at right here. That flips this the tilde flips bits, doesn't it? That just means inverse, right? Flips all bits, yeah. Oh, I forgot about these operations. I could use that up here. There's a place up here I could use that. Right here, probably. Oh, right, there's another. Oh, I see what this is doing. This is getting me to the location of the bits that I'm looking at. Modulus. Okay, that's... Which line are you talking about there, Dizzy? When you add 1 to a pointer. Oh, okay. So I'm essentially on the right. So I'm essentially on a similar path. Let's try and see, but I already got, so I got offset already. If you just subtract straight pointers from each other, will that just... Is that a usable offset that you can just use? Must be in a... Because I need to... If I wanted to do this, I need to cast this to a frame. Then, like this. Offset is a byte offset. Yeah, that's what I was going. That's what I was going for. But it's types are confusing me at the moment. No super. Oh, frame pointer. No super. Yeah, like so. No, wait. Let's try this. This is my solution. Let me get rid of this. Blah, 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 blah. Framed free. That's got to be a... I'll cast that too. Frame pointer. What are you complaining about? Modulus. Yeah, okay, I see. Yeah, see, so it's stuff like this that I'm not super knowledgeable about, but that's why I like kind of learning about it. So this is a much more concise way to do what I was trying to do. So the address. So let me run through this one more time to make sure I understand. So bits, we're taking the address of our frame field, the difference, which will get us an index into our frame field bitmap, divided by size of an int divided by 8. So that would get it down to chars because I treated this because this is an integer. And then the mask, which finds the exact bit that I want to flip back again, is again that byte difference divided by Size of an int divided by size of an int. By the number of bits in an integer. Okay. Okay. Bits equals... Oh, I see. So the one bit that we want to turn off is the one that we move in, and then and it with the flipped version, that'll be a 0. Elegant. I like it. So now, we can try it. So theoretically what should happen is we allocate our first page... We have to do these in... If we want to do this, check this out actually. So we gotta make these individual variables. I can't keep rewriting the same one over and over again. 0, page 3, that's fine. So, if we make... How second nature to you now? Yeah, it's something that I would really like to get a lot better at, because you can do some really effective and efficient stuff with it. Free. Free frame, yeah. New page. Why do you not see that? No. It's in right there. Do I need to cast it? Oh, do I need to make it a void pointer? I don't think you can cast that though, can you? Why do you not see that? It's stuff like this that bothers me. It's not declared in the scope? Yeah, it is. See, that's the other problem with... You shouldn't need to cast... That's what I thought. I'm like, it should just figure that out. But see, that's the other problem. Like, my IDE, which is Visual Studio Code, it knows I'm using C++. But because I'm not using any of the standard library stuff, and I haven't figured out how to, like, have it automatically reference my system headers and stuff, it tries to help me and doesn't understand that I don't have access to stuff, and... Hey, Malcor. Thanks for the follow. Appreciate it. This has got to be something stupid. Free frame. Hey, Mal. Thanks for joining us. For watching me struggle. Why do you not see that? You see... It sees find new frame just fine. I don't think I didn't have to put that into my system, did I? No. Should see it because I have that. Is it because I'm doing auto? But it's returning a void frame, so that shouldn't matter. So that should become a void frame, a void pointer. This has got to be some stupid mistake that I'm not seeing. See, that's why I need friends. That's why I need smart people. Oh, I didn't save my kernel. Alright. Abolish header files? Really? What are you going to do instead? Just include other CPP files? So I don't think this worked. So the first one that I allocated was at the first spot, which is new page. The second one I allocated was in the second spot. Then I freed new page. Isn't Zig another language? I've heard about it. That's like kind of like C. What? 2 million lines in one file. Yeah, that's what I'm saying. Your free frame didn't work. So it should have, my third allocation should have reused the first location instead. So I wonder why. I guess I could print out... I could go ahead and print out mask to see if that's getting calculated right. I don't have a binary printf formatting, but we can just use the calculator. Just get it as an integer and then convert it with the calculator. Just see what it's doing. Well, that's informative. Oh, I think we went in from the wrong way. So, I think the shift needs to come from the other direction. See what I had to do here? Because we're actually counting from the most significant bit downward. Yeah. Which is basically essentially what I did here. This is a super ugly way, and I really love to know if there's a nicer way to do that. But it's because I'm dealing with bits. 31 minus, and not bytes. I mean, I guess I could do size of int times 8, and that would look a little cleaner, I suppose. But there's not really a... Aha! Okay, that's really weird, but anyway, so that printout's totally off. But that worked, because now we reused the original location. So that's good. Win. Yes. Okay, I'm gonna get rid of this, because, I mean... So, when I eventually put asserts in, too, there's a lot of places I should do asserts. So, find the index into the bit map. Find the specific bit to flip. And flip it. I know I'm going to forget how this works later, because that's what's been happening this entire time. On this whole thing, I forget how pieces work. Okay. So, I can free and allocate 4 kilobyte aligned pages. Or, frames. Gosh. So now, I need to just keep track of those in my... See, I don't even know necessarily how this is going to work yet. I've already got nice classes for my page directory entries and my page table entries. So, what I need to do is, as I allocate pages, I don't even know if any of this works yet because I haven't even been able to test it yet. But as I allocate new frames, they get saved in here. So the idea behind this, I'm trying to get to running multiple processes. I'm trying to get to threading. Because once I can thread, then I can run separate programs. So I haven't really figured out what my multi-process is going to look like. But ideally, what I believe is the right thing to do is to give every new process a new page directory. And every page directory can hold 1024 page tables. And every page table can hold 1024 pages, which is what I just made myself the ability to allocate. 32-bit i686, that's what it is, yeah. The vanilla one that every online tutorial starts you out on. But you need paging to be able to do 64-bit. So, if I get paging working, I could move on to 64-bit if I wanted to. You just stumbled onto my channel. That's nice. I'm glad you made it. Yes, the directory is the topmost. I mean, I don't really... I think you really only need that just so you can get to the entire address space, because pages are 4 kilobytes. You can have 1024 of those, and then you can have 1024 sets of those in a directory. So it's 1024 times 1024 times 4 kilobytes. That gets you to 4 gigabytes of address space. So I think just the multi-level thing is just so you can get to more space. But I mean, ideally what I would think to do is... Because I'm also kind of confused about the best way to... I'm trying to think ahead. I've seen some people that also map part of their the kernel into every address space, so you can do stuff like system calls. But I haven't really thought that through yet. Dang. No, it's been an uphill struggle. But it's really cool. Because I'm learning lots of fun stuff. And you guys are more than welcome to check it out if you want to. If you want to... There's the GitHub repo. It's linked down below, too. If you don't want to start from scratch on an OS, you're more than welcome to submit a pull request. No. Nope. It's personal. I got antsy one day and decided to give it a try. I saw some other really cool looking ones online and thought, you know, why not? I feel like I'm just barely skilled enough to be able to try something like this. Like, there's a lot of stuff I don't know, as I'm sure you guys are well aware just by watching me now. But I do feel like I'm able to go learn stuff that I need to. Which is just barely enough. Okay. So I don't really know where I want to go in regards of setting this up, so I might go ahead and put that off right now. 15 years or so. What do you use normally? This is actually C++, technically. This is compiling a C++. 5% sweat. It is slow going. It has been really slow going. I've only been on it seriously for the past maybe, I don't know, three months or so maybe. I started it at the beginning of this year. Like, I actually made the GitHub repo, like, very early this year. But I put it off for a while. So something that I think I would like to go ahead and put in, though, real quick, is I've put a lot of these to-dos to do asserts. And I was actually goofing around the other day with a scratch-made assert, which I think I might have figured out. So I think what I do want to do is go ahead and put in the ability to do asserts. Hey, Omobo. You did a pull request? I did not see your pull request. When did you put it in? Oh, I didn't see your pull request. First time contributor. Nice. Oh, you worked on my makefile. That's what we did last time, was work on the makefile, and it's all in all its horrendousness. GDB debugging. That's another great thing that I should really look at. Yeah, I'm getting to the point where, like, I want to add new features, but I need to put in the infrastructure behind it to make it easier for me later, is the thing. Sure, why not? Go ahead. Yeah, no pick. Oh, that's another flag that I forgot. Yeah, you're right. Make their parent. Yep. Place the flags. Yep. Oh, you figured out how to do if statements inside a makefile. I was looking for that, actually. I was looking for a way to do something like this, actually. I mean, to be honest, guys, a lot of you guys have really helped me out a lot of the time, especially like Mobo. He's been watching me for a while. Like I said, I'm learning new stuff every day. I didn't know a lot of this stuff. Did you... I feel like I tried this one, actually. And I could... Mobo, and I could only... Where's my feeble break? I feel like I could only do a PowerShell to run a command, but if that's a way to do it, then I suppose that works fine, too. I don't know if it really matters. preserve the path. Yeah, like there might be a nicer way to do this too, because that's just where I happen to have it. A relative call to the kernel. Oh. Let's see. That's kind of cool. Preserves the path for you. Okay, that makes sense. This is a super hacky way, so it's cool. Thanks. I like it. After I commit here, then I'll pull it in. Because what was I gonna do? Oh right. So I was gonna give asserts a good try. Yeah, a couple of other people have compiled it actually, and it was so cool. Like this is so like I've never done anything like this before either. I've never had like an open source project that other people have worked on or looked at, or it's pretty neat. I'm really enjoying the experience. Okay. So I was messing around with some possible assert logic earlier, and from what I understand, the best way to do it is to just use compiler macros, because they can give you the line and the file that the assert was triggered in, which I think is really cool. A 5-year-old throwaway project. Did they do a pull request? Did you just give it to him? It's like, fine, put it in. I don't care. Alright, so assert.h. Assert h. Define assert h. If h. Okay. So, the two kinds of asserts that I think I would like to see is the assert where it will check your... Oh, I think I said I was supporting it. Yeah. I didn't have a license on mine until just a little while ago, actually. Until someone in the chat mentioned it. It might have been you, Mobo. I put one on. So, void assert halt. Actually, no, hold on. I should just make these defines. So, define assert. Well, actually, what's the nomenclature? I think there's one called assert not reached. And that's one that you place in you put somewhere that you don't expect it to ever get to, but if it does, it'll warn you. And that one, if I believe, doesn't take any... You take any arguments. And then there's another one that's assert, just a normal assert with a condition or an expression. And so the expression one is if the expression is true, it triggers. So I think, is it if no, if the expression is false. Like that. And this, I was messing around with this earlier, and this macro like argument passing is really weird. Is that the right one? I can't remember which. You have to do like a backslash on every line to keep it. Actually, I do want to include debugging. Where's debug? It's just debugger device. What's the print? That's what it was. Oh shoot! I don't have formatting available for the debugger, so I guess I'll just have to do printf for right now. Oh. So they call this one check. That word actually makes more sense to me. Xlog fatal. Yeah. Yeah, this is basically, this one's just basically a stop if you ever get here. So you put not reached normally in a place that you wouldn't expect it to ever get to. So like if you had a bunch of different return statements and you weren't able to get to one, I mean that might not actually be allowed. But if you get to the end of something and you hit an assert not reached, yeah, then you'll know you got somewhere you weren't intended to ever get to. A switch, that's a good place for it, yeah. So like if you didn't hit any of your cases or something like that, that'd be a good place for it. And then the idea here is that we can use... Oh, I need standard IO, that's what I need. Test-driven, yeah. Oh, nope. libc standard IO. There we go. So that's got printf. So what I would like eventually is to have... I'd rather have this print out to like the debug console, which is the serial console, but my serial printing doesn't have formatting capability. So I can't do what I'm about to do here. I want to also have it print out the line number and the file that it's currently in, which I found out you can do is pretty neat. So I think if I check fail, I think I can just do as a string. And I think you can do # expression to make it a string. Fail s file. That's also a string literal, I believe. And they give you this really cool macro that's called file. And they can also tell you the line number, which is a decimal. So false equal. Yeah, so this should tell me what the expression it was checking was, what file this is in, and what line this is on. You can concatenate string. You could count a string debug printf. Which one are you talking about, Dizzy? This one? Yeah, that's what I'm counting on right here, because I don't actually have a string. Line is an integer. I'm pretty sure. Oh, expression in here, is that what you mean? I'm pretty sure line is an integer. Oh, I see what you're saying, Striker. I don't think I have the plumbing in for that yet either, though. Why is that not happy? Expected a declaration. Oh. Right? Really? Because right now, all my... It takes a char pointer, actually. So I could just do... Really? I can do that? So you're saying here instead, let me get rid of that. Let me pull in include debugger device. So instead I could just do... Oh, I might not like that. Yeah, I was about to say, like, that's not going to work, is it? Let me just get rid of that. I live dangerously. Oh, I got to do debugger device. Debug logger. Instance. Oh. You mean this? Maybe. Then it doesn't. Yeah, then it doesn't like that. Yeah, I was pretty sure it was. Oh, I was pretty sure it was backslash. Print. Oh. Check. So you mean I can just do... I can just put them one after another? Like that? It's pretty neat. File... How's it gonna work for the line number though, as an integer? Will that just float right into? I don't know if it'll be treated as a string literal. Oh, the one up above. Oh, treat it as a string. Perfect. That's exactly what I did with expression. Yep. Which treats it as a string literal. Expected a macro parameter name. That'd be really cool if it did work. Trying. I wonder if there's a smart way to do that. Hold on. Line to... Oh, line to string. Is there a way to do that? Is there a stringify preprocessor directive? Stringify. Yeah, that's kind of what this says here to do too. Define string. Well, that's what we're going with right now. X to be X. Macro within a macro. Love it. Love it, love it, love it. Oh. Well, it's a... Well, I feel it's kind of the same as the way I'm using expression, even though I named that myself. Why is that not happy? Expected a declaration. Why are you not happy? Is there something I'm doing wrong? Macroception. Function like macro, blah 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 blah. Those are just calling other functions. Doesn't like that. Oh, is that not actually necessary? Why are you... expected a declaration. Where you go? Instant? Oh, wait. That's wrong. Fix that. But, why are you not happy with that? Because the backslash just makes it act as if it's all on the same line, right? Which is what I want, because I want to make sure that the line number stays on the actual line that the assert gets written on, so it matches. If false expression, blah 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 blah. No. 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 Those are all the macros. Yeah. I know that. Just for fun, I'll put it somewhere and see what it'll tell me. Assert each. What did I call it? Check. 2 is equal to 3. Get rid of the paging test. Just for fun. New line separated by a space. What, really? Is that it? Backlash new line separated by a space. Which one's it? At the end of line 13. The backslash is escaping the literal new line. You talking about on my... Oh. You mean all that? Ah. Oh, wow. I had an exception. Hey, Tyler. Welcome to the party. Why do I have a... Is that an error? Okay, this is weird. This is really, really weird. That's exactly what I'm trying to make. Yes, we are partying to assertions. I'm trying to make at least something. You know, usually, just for fun, make it hang there, see what happens. Oh, here it is. It's printing out. It is printing out in the console here. That's what I wanted. So looks like, I think, Mobo, your suspicion was right. We are getting the physical representation of line and not the actual variable. But I think... Oh, and also it did hang there. Let me show you. See? So it hung there. I don't know why I was getting an exception. I'll deal with that in a minute, though. Yeah, I agree. You think just like that with no hashtag #? Get hurt. Let's try it and see. We're learning all sorts of new things today. No match to... Wait, what? That's what I was thinking about there, Stragger. Yeah, I saw you write something else. Let's see, where were we talking about that? Do line number, stringify. Have one define another. Equal, see what were we doing there? So stringify 2 of x, and then define stringify 2 of x to do the... How is that helping, though? Does that trick the compiler into doing something? Sure enough. So on kernel line C... Oh, I gotta add some spaces. Line 67. Oh, whoops. Turns line into a line number. Got it. That's kind of roundabout, but... yeah, this is why I generally don't really care to use preprocessor stuff, but there's not really any other way in this case. So let's make sure. So line 67 is exactly that. Oh, is it going to complain about that forever? Whatever. In theory, if it's passable, it should not have a problem. It goes away in C++ 20. Well, that's what I made this one. Yeah, that's what I made that one do. So I'll leave it at that. So that still works. I wonder why it was exceptioning when I allowed it to pass through, though, but... source location? Is that a C++ 20 built in? I'm only enforcing 14 at the moment, I believe. No, 17. But I have no runtime library either, so it wouldn't actually matter. Okay, so what did I want to do with it? Oh, so I wanted to do assert not reached either. I guess I can go ahead and put that one in too. It's basically the same thing, only without checking the expression. Fine. Assert not reached. To be logger instance print. So this be assert not assert reached file line stringify line. Wait, I need that. Oh wait, no, I do if I want to do a while true. Okay. Let's just try that in there. So. Doesn't autocomplete for me. not reached. Oh, did I miss one? There it was. Yep, you're right. Okay, see, there we go. We held. There, we printed out. Assert reached. Right there. Good. Why? For having multiple definitions of the same preprocessor? Why would you want to do that? Assertion failed. You mean the... Which one are you talking about, Strager? The check or the not reached? $19 and... That's what I'm... Is there a better way to do it? Imagine if P is null pointer check. Yeah, copy and pasting, I get it. So in this case, I make a function call assertion failed, which does the print. And the loop. So I see what you're saying there. I think I see what you're saying there, Strager. So I could do... Oh, so you're saying this not reached one would be better as a failed? I see what you're saying. That just requires the check for whatever it is to be done manually, but like the way you just pointed out. There's a macro trick. You weren't? Maybe I'm not understanding then. Are you saying I should make another one for assertion failed? Strager? Assertion not reached. Okay. Sure. If false. Ah, crud. Is this what you were getting at, Omobo? What happened? Multiple statements. Turning Turning off. This is great, guys. This is great. None, no, no warnings. Okay, so we got nothing, and we're hung. Oh, well, assert not reached. Well, no, assert reached should have printed something. Why did we hang? Did we actually get inside? You guys are laughing at me. I have a feeling it'll make complete sense. Assertion not reached. Blah blah blah. I had to have hit that. Is this some funny macro behavior that I don't know about? I know, I should have printed that if I had gotten there. There's a new line. I should never have gotten right there. Blah, 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 blah. Hold on. Assertion failed, which does the print and the loop. You're probably right, Mobo. Saying I should just throw this in there and see what happens. I put them there because this is multi-line. Does that have something to do with it? So in order for that to work, I have to leave it as with a backslash to put that on the same line, right? Blah, 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 blah. Still does it. Putting on the same line literally means putting on the same line. Come on, go away. Do you guys enjoy watching me struggle? So, the fact that this behaved as I would expect, does that mean I'm missing something in here? Is that what you guys were talking about? Blah, 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 blah. Yeah. Check is one big. Yeah, so I should surround this with something, shouldn't I? Is that what that do while false idea was? I mean, it'll hang. Oh gosh. Yeah, it's all macro crap that I don't know about. Like that. Oh wait, no, I don't need that anymore. So if I get it. I get it. It was treating only this line as if under the if statement, and then getting stuck on that line when it was copy pasting. Yeah. So simple. So simple. Because it adds brackets and it'll add you brackets and guarantees that you'll get it in at least once. It's a beautiful language. Isn't the saying it'll give you enough rope to hang yourself with? Now that warning makes a lot of sense now. Yeah, makes a lot of sense now. That's what I expect. Oh, let me put this back in. false? Yeah, blah, blah, blah. True. Yeah, that's I was going to. There we go. I'll put my my W error back in. Put them all in a wrapping them all in a do while. Makes sense. Makes sense. Do. Oh, white space. Here we go. White space. While. Okay. Now that took way more brain power than I was expecting. Let me put this a couple places and see. So one place that I did just have it here is I did want to make sure. It's like here, we want to make sure that frame to free is larger than frame, to make sure that the address we're trying to free is in fact after the beginning of our frame field. Because if it was before, something would be totally wrong. So in theory, magic number, no bueno. Yeah, right. So I'd want to do something like check that. Can you just compare pointers like that? So that frame to free is greater than frame field. That's gonna bother me. I need to figure out how to give VS Code a way to source my H files. Oh, I didn't take out the thing. I don't have STD. Int pointers. Where am I? There we go. Make them numbers. Oh yeah, I do, because I can have the first frame I'm freeing can be the beginning. Yeah, that makes sense. Assigned int pointer. Oh. Yeah, I see what you're saying. I'm not used to seeing all those like the underscore t's. Yeah, so make them actual numbers and then compare them. That makes sense. Oh, I'm not running the test actually. Yeah, I gotta actually turn on my paging test. It probably should not be called paging because it's just allocating frames. Yep, so I survived. Is there a way I can... I could just pass it an address that's too small. So, like in here, if I do void... Oh, gosh. I hate this keyboard. Fail equals... $30 million? I can't just do that, can I? There we go. Now if I pass it that, it should fail because that's going to be less than... Is that right? 1, 2, 3... 30 million? Yeah. Because that's going to be less than my beginning. And that's not a frame that I can free. Hopefully we should hit a search. Or we should hit our assert. Crap. Why did that not work? Oh. That was silly. Frame field. That's what I want. Of course it's equal to itself. Okay. Hey, look at that. So we stopped. Unsigned. Had a check for setting something equal to itself. Does it? I don't know. But that sure is heck. No, let's see. I was confused by the casts. Autological comparison. Might be a good thing to add on to my... I'm kind of curious what... Let's throw it on there and see what happens. What is it? W... So... Logical... Warning everything. You should. Oh, T. Did I read that wrong? Oh, T autological. My chat's really small. I'm having a hard time reading it. So theoretically, that should stop me. That should stop me if I do a... tautologically? Some stuff's abbreviations, some stuff are letters, some stuff are actual words. I don't know this stuff. So if I do something like 2 is greater than or equal to 2, that should stop me. Do I have to actually put a command line? Oh, T autolog. I can't spell. Compare. There we go. The compiler caught it for me. It's fine. No, make caught it for me. Oh, didn't seem to have a problem with that. Is it only good for variables, or does it work with constants too? Yeah, see it blazed right through that. See? Only variable names. I'm curious. Let's try and see. This equals. Oh, int x equals. Okay, int x equals 2. So if I do x is greater than or equal to x. Yeah, I wonder why it wouldn't work for constants too, but I'm just curious. Ah, there we go. Self-comparison always evaluates true. Well, we can try and see here. Bobo, we can take. Let me take that out and see if it catches. Because I do have W all, but it looks like it didn't. Oh. It did. Yeah, so I mean, like, the thing is, though, these here aren't necessarily... Well, frame to free is known. Oh, the casting? Yeah, maybe then it doesn't... Maybe... Because at compile time, this variable exists at compile time, so that would say, yeah, it should be equal to itself. But then maybe do casts happen at compile time too, don't they? Put in another one there, Stragger. Put it into that version of GCC 10 you just built. Okay, I like that. That's good. There was another place. Oh, assert that major and minor are not equal to -1. That's a good check too. So I initialize these index numbers to be -1. Doesn't warn you if you have casts. Did you expect Clang to warn you? Check major index. And that's what I hear. I hear Clang is a little more verbose on stuff. There's a limitation there though, since isn't bit pattern of integer versus pointer technically not defined. As long as a void in pointer sum compares equals the original. Oh, really? Basically, none of GCC is good. So I could overwrite the implementation of a cast if I wanted to. Oh, I've still got that in there. Yeah, so it looks like W all catches that though. Nice to know. So I triggered something. I just triggered something here, so... Oh, was that too early? That might have been too early. That's too early. They're still equal 0 at that point. I gotta do it below. Right there. Nope, no. hate this freaking keyboard. Do it there. Because that's before they'd been set. Oh, I'm forgetting all my old tests. I still have this in here, too. It means compiler decides. User defined means the programmers, the compiler can decide, so you... Oh, behavior pointer. You might be able to control the behavior using compiler switches, though. The compiler decides. Well, that's because I start them out as -1. And to make sure they at least found something. Because you don't want... Because I'm going to index into an array using that. I don't know if it's strictly necessary, but maybe I'm just looking for excuses to use this. Yep, there we go. No problem. There was somewhere else that I had a idea for an assert also. Both start at 0. That's true. Should I make that... I guess, is there any reason... Didn't you... Outside the loop? I mean, I use it right here, though, inside, so I'd want to... I feel like I'd want to check that before I actually use it anywhere if I was going to. Oh, these? Out here? Yeah, because I use them out here. Yeah, they're out here. The loops are designed to just set them to something that's appropriate. And then stop when it finds good values for them, and then use them out here. Isn't that where you want to check them then? Outside the loop, yeah. Oh, because they're still being edited in there. Oh, I see what you guys are saying. Yeah, I suppose. Yeah. So after they're done being influenced, check them outside. Move lines 52 and 53. Well, I just blah blah blah. Into the loop, 49. Oh, so both of these should go, oh, let's see, hold on, so into 49, so right. Oh, I see why that would work. Yeah, because if it breaks out of this loop, then it must have found that means it's found both version or both numbers to be correct. Yeah, that's a good idea. Put those in here. Assert not reached. That's good use for it. Right, so if it hits either of these, or if it hits this, that means for some reason it couldn't find a... of usable bit, I suppose. Yeah, I like it. A double fault. Huh, it worked that time. Crashes. That happened. No, it's working now. That must have been a fluke. Weird. Shoot it. Ship it. Yep. It's a lot less than that, actually. I've run this probably several hundred times, and have only had maybe I could count on one hand maybe how many odd, maybe both hands, how many odd breaks it's had. Have you tried turning it off and on again? Okay, where did I had another place I wanted to. This all my to-dos. I can't search I can't search all my files, can I? Dang it. I was thinking I should make a script that searches all my source files and finds all my to-dos. There was another place I wanted to put it. Oh, was it in my No, was it in my debugger device? No. Does that search everybody? Oh. Grab to do. Yep, there you go. To do. I just pile up. I thought there was one more. Maybe I'm lying. Oh wow, ISR helper has a lot. Oh, there it is. Assert that the physical... shoot. Oh, I could just do, It's 4K aligned. Yeah, I could do one there, I suppose. Is it really necessary, though? I haven't even gotten really into testing this yet. So this is the class that I'm going to use, that I'm going to use to keep track of the frames that I just figured out how to allocate. And they have to be 4 kilobyte aligned addresses, but I made it to where the allocator picks 4 kilobyte aligned addresses. So I don't really know if there's a... I guess this will keep you from accidentally shoving any old address into here, into one of these. Out of sight, out of mind. Get to it when you get to it. So I don't really know if there's a need to do a check here. The only reason you'd want to check this here is if you shove some address into here that wasn't given to you by the frame allocator. Because the frame allocator gives you 4 kilobyte aligned addresses, so this won't matter. Boom. Is that regex? I'm not very good at regex. Check that address and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know sed. Sed's pretty cool, but like regex doesn't work very well in my head. I'm not very good at it. I guess I haven't really practiced with that, I suppose. If I practiced, I'd probably be okay. But must have an integral. Oh, can I just do unsigned int? There we go. Don't know if that'll ever be a problem, but that'll stop me if I try to jam any old address into an unpacked table entry that's not 4 kilobyte aligned. So, I don't know. Make sure I don't break. Oh, shoot. Oh. You don't think the check is doing what I think? What you think I'm? What I think it's doing? Include assert. Well, let me think about that for a second then. I want. Oh wait, 0 through 11. Wait, 0 through 11, really? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4, 8, 12. That's the first 4. Those are the first 12 bits. Yeah, that's 0 through 11. And oh wait. Ha ha ha. Past self helped me. Or, yep, that's what I want. Closer. If int editor host. Try it with 08 blah 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 01. What exactly would that do if I throw that in there? Oh, wait a second. That's way too many bits. It's not. I only want it to be... No, you're right. That's not right at all. Yeah, no. That 1 on the end there, Striker, would make it through. digits of a 32-bit number. 4, 8, 12, 16. It's getting late, guys. 1, 2, 3, 4, 5, 6, 7, 8. There we go. It's the wrong operator. You're right, that's not doing what I want it to do. I only want it to make sure that the bottom 3 are zeros. I'm just thinking through the other logical operators, or the bitwise operators. Oh, do I need to... or with... Oh, I'm making sure that this is... No, I'm making sure that this assertion checks to see if it's false. So I do want to make sure that these are 0. You're throwing away the bottom 3 bytes. Brain power is dwindling very fast. You guys probably know exactly what it is. Oh, yeah, they are nibbles. They're not bytes. 2 of them is a byte. I want to make sure that the bottom 3 are zeros and the rest can be whatever they want. Page line, unsigned int, address, return address. Hold on, let me think that through real quick. Oh, you're giving me the answer? Unsigned in, physical page address, blah, 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 is just... just the 3 bottom nibbles. Yeah. That makes a lot of sense. I only care about... and I want that to not be true. And... yeah, you're right. theoretically, I can go ahead and... Well, I should be able to try this, actually. I haven't actually used this thing yet, but that class yet, but what if I go ahead and try making one? If I do... One equals... find new frame. So this one will be a correct one. So then... let's do auto. This is just to experiment to see if it works. New... Oh, I want to do that down... Oh, shoot. I have to... See, I've got two versions. One where you can pass in all these things individually, and then one where you can just pass in an integer where they're all jammed together, which is what that format actually is, and it breaks them apart. Oh, wait a second. Looking at this now, this probably won't work either. For the same reason as here. That should be an and, shouldn't it? Right? Because in this case, I do want to throw away the bottom 3 bytes, or nibbles. Alignment functions. Might be a good idea. You're probably right. Yeah, it goes back to there's a bunch of little assistant stuff that I really should go through and put in. Let's see one unpacked. So entry. Header 1. In that constructor. Yeah, I think I got those backwards. You are correct, because I only want the ones that I'm actually specifically talking about. Yep. If you guys were so inclined, you are more than welcome to put your name on the contributor section on the README at this point. Yep, you're right. A lot of this I'd have figured out eventually, but it's a lot easier to figure it out now. I don't know. Just fill in all this random crap just to see if it lets me through the constructor. How many were there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, no. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, gosh. Unpacked. Void. Oh. Uh... 255, that's a char, isn't it? Let's put 0 in there right now. I want to test this. Why are you not? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 booleans. Why is that not happy? Oh, unsigned int adder. Is that what I need to do? True, yeah. There we go. So that should be allowed. And then if I do another random one, equals void OX or 1, 2, 3, 4, 5, 6, 7, 8. This should be 40 million. Bump. 1, 2, 3. Nope, 1 less. And then, I don't know. Does anything in its first 3 bits. 1, 2, 3, 4, 5, 6, 7, 8. Then it should fail. Okay. Unused parameter. Oh, I don't care. Wait, why? Where? In the constructor, unused. I did. Whoops. Yep. What did I call that? This is a sign that I should probably not be doing this at this point. I don't care. Unused oh. Do I have to define an equals operator for this to work? No, wait, I can do can I just recast it? Can you cast as an auto? No. Can I do I can do void. Can't I? Yeah. Void pointer. Yeah. Void pointer. Just to make the compiler happy. Statement. What? Well, I don't care what I cast them as because I'm not going to use them. Yeah, I've casted a void before. Ah. Ah. Ah ha ha. Yeah, void test, yeah. That's what I got. There we go, see? And it failed on... Oh, that's interesting. So it's... That's interesting. Because it's telling me that it failed on the line in the constructor. That's where the actual assert is. So that doesn't really... That's not super helpful in debugging, I suppose, because it could have been either one of these. But I mean, it does point out that it's in the constructor of one of these, so that's reasonably helpful, I suppose. At that point, I would want to see a stack trace. GDB. But that's cool. I can make stack traces? I'm sure I could. Can I right now? I have absolutely no idea. Will I learn? Probably. Symbolic stack traces, no. It's getting late. Oh my gosh, I've done a lot of stuff. Let's see what my address to line. That's kind of cool. There's a space, whatever. Keyword. Wire GDB, yeah. Add a comment, okay. Get status, where was I? So get memory. Get add source kernel libc memory. That was just one commit. Comment. Yeah, whatever. Those I just removed. Get add source kernel arch source kernel driver keyboard source include patch to Chrome. Oh yeah. Let's see, run it on an 8 GB machine. Pixar didn't happen. Git add. Yeah, I know it is. I just never got around to it. It's the same thing. The same thing with the serial, the serial port that I did earlier. It's not that hard. It's just something I never got around to doing. I think the rest. Oh, except for assert. Git add assert. No, it's include. And then git add the rest. Status. Push. Need to do an SSH key. All right. That's that. So, I will go ahead and pull in your... Well, actually, first, let me go ahead and do a git. Well, it's not part of the... It's not merged into master yet, is it? Once I pull it in, I'll try it out and see. I think that's all I wanted to do tonight. Thanks, guys, for being so interactive and so helpful. This is a learning experience for me, and you guys are obviously a lot more skilled at this than I am. I'm probably the least qualified person to be doing something like this. But that's okay. That's how you become qualified. For anybody who's been lurking, also, there's the GitHub link. If any of you guys want to pull it down and build it. That's true. That's true. Very, very true. But, yeah, so, again, anybody is welcome to pull it down, give it a try, make tweaks, put in a pull request. Now that there are people who are actually interested in doing pull requests, I'll pay more attention to that. It's been sitting there for a while. Sorry, Mobo. But yeah, so you guys can reach out to me here on Twitch or on GitHub if you want to. I'm thinking I might make my Discord available at some point. If any of you guys want to contact me that way. Links are also down below. My GitHub is down there. My YouTube channel is down there too. I've been uploading these streams to it just for archival, just because they go away after a while. I'm a little bit behind on that. I need to push a few more on there. But yeah. So again, thanks for following, for joining me this evening. It was a lot of fun. I had a lot of fun. Got some good progress done. Thanks to some of you guys out there. I try to work on this a couple times a week, if possible. Yeah, for Dark. Yeah, I'm a few videos behind, so I need to get up on that. They only last for 14 days, unless you're a partner. Then they last for 60 days. Yeah, but if you guys know anybody else who'd be interested in following along with them, please point them my way. I'd love to get more viewers and more people working on this. I think it'd be a lot of fun to get some more people working on it. So, yeah. pretty late here, so I should probably go to bed at some point. So to all of you guys, thank you very much. Good night, and I'll see you guys later.